Hello, friends. In the series of learning computer organization and design, today we are going to focus upon addressing modes. So, before beginning, as we are already aware, we are learning the concept of central processing unit. We have already covered all these topics so far. So, today the topic of discussion is addressing modes. So, let's understand about the addressing modes in more detail. So, before beginning with understanding the different types of addressing modes available, let's start with the introductory part of what are the addressing modes. So, basically, addressing modes are specified within the instructions, they are having the relationship within the instruction. So, in order to understand any particular instruction, it is important that we should have a knowledge of the various addressing modes existing. So the very first thing is addressing modes within the instructions are present like, let's suppose this is one instruction. It is a format of the instruction. There are certain bits in the instructions. We are calling them as the address bits, right? Then there are opcode bits, and then there comes the mode bit. So this mode bit is nothing but the addressing mode bit. Now, the point is that what is its significance in case of the instruction? So, the significance is that it is specifying me a rule for interpreting or modifying the address field of the instruction. So, generally, what it is depicting is that it is telling me, it is instructing me that how I am able to work upon the address field which has been present here in this particular instruction, right? Before getting the required data or operand. So the idea is whenever this instruction has to be operated, so definitely this address bit, these bits which are available here, okay, these address bits will specify me the address of the memory. But how I have to work with this particular address field, this will be signified by this mode bit, okay. Then second thing is that why we are using these different types of the addressing modes. So there is again a valid reason for that. The very first thing is, as here there are number of different kind of addressing modes available. So the reason is that why these are various types or various in number, because it is giving me the flexibility, the programming flexibility. So by programming flexibility, I mean that so in the programming I am using a number of ways to get the data. Like there are some control statements, conditions being there, right? And some branching, some sort of interrupt kind of mechanisms being applied. So, in order to meet all these programming requirements, what I need to have is we are having a variety of addressing modes which are existing within the modern machines. Furthermore, the second point in this regard is in this particular instruction format, these bits which I am signifying them as the addressing bits would be there, right? These address bits are, you could say that, limited in number. Now whenever I am having a variety of addressing modes available, it means that I can use these particular address bits in a number of ways, okay, so that these bits can be used efficiently, or you could say that for the efficient use of the bits which are available in instruction, we are using the concept of the addressing modes. So again, as I have already discussed with you, so there are different kind of addressing modes which are existing within your modern machines. So like direct addressing, indirect addressing, we are already aware of this because we have learned these two in the basic computer configuration. But the other addressing modes, implied, immediate, resistor indirect, auto increment, relative addressing, index, and base resistor indexing. So we are going to learn in detail about all these addressing modes. So let's do that. So the very first addressing mode in the this particular series is the implied mode. So implied mode is a kind of addressing mode which usually requires no address field. Okay, so there is a no requirement, so no need to specify the address in the instructions. So what kind of mode is this and where we can use them? So address of the operands are specified implicitly in the definition of the instructions. So when we are defining the instruction, some instruction is there. Let's suppose this is one instruction. This instruction is normally the meaning of this instruction is the complement accumulator. Okay, so instruction in itself is signifying me that okay, whatsoever the value is present in the accumulator, I just need to complement that. So means I need not to perform any operation on the memory. So that's why such kind of instructions are called as the implied mode instructions. So all the register reference instructions as well as the instructions which are called as the zero address instructions. Okay, so zero address instructions, one address, two address, three address instructions we have already discussed in detail in the instruction formats. Okay, you can watch that recorded session in order to understand more about what is a zero address instruction. So usually for your simplicity I am just telling you that zero address instructions are also the instructions which are based on the stack organization. So that's why, so they doesn't require any sort of addressing bits or effective address, but the data which is available in the accumulator, okay, or the data which is pointing me the stack will always point me the top of the stack, right? So this data will be provided here in this immediate mode. So no need to specify a specific address where you have to reach in the memory and all. So this is what is the employed mode. Then, secondly, there comes the immediate addressing mode. Now, immediate is also similar, quite similar to employed. Reason being, it also doesn't want the address to be specified within the instruction. Why? Because as the name specifies, immediate means I am in immediate need of the operand. Okay, so just try to understand the meaning. Instead of specifying the address of the operand, operand itself is specified. So operand is nothing but the data, whichever the required data is been needed by the user, it directly is present here in these instruction address bits. So that data can directly be used in the instruction. So this is what is the meaning of the term immediate addressing modes. So, however, operand itself needs to be specified. So, you need to specify that exact operand which you want to use. Sometimes it also requires more bit than the addresses. So, the reason is so much validated because it is not the address of the instruction, it is simply specifying me the data. So, usually immediate addressing modes are being used if I am in hurry to acquire the operand value. So this is how we can use the implied and immediate addressing modes. So the next kind of addressing mode is the register mode. Register mode, or it is also known as register direct addressing mode. So why we are calling it so? So the idea is that the address specified in the instruction is the address register. So whatever the instruction, whatever the address will be specified here, okay, that will exactly be the address of the resistor. Let's suppose this is R1 resistor having some value. So whatsoever the value will be stored here is directly been used, okay, by the resistor for the computation. So designated operands need to be in the register. So whatsoever is the data is directly being present here. That's why it is called register mode or register direct mode instruction. So shorter address than the memory address, obviously, because I just need to signify the register only, the data saved here, right? So fast to acquire the operand than the memory addressing. So these all are the properties which are associated with the register direct mode. Idea is again very simple. Let's suppose this is a resistor having some value 100. So if the address is specifying me some value, okay, let's suppose this is the 100 value or address. This address is directly the address of this particular resistor. So this is how I could say it is a resistor direct. Directly within the resistor, the operand is present. So this is what is the meaning of the term. The next is the register indirect mode. So please mind it. Here I was using the term resistor direct. Here it is resistor indirect. So the mean is that whatsoever the data is available in the resistor, it is referring me to the resistor address only, but indirectly. Now I have to reach the memory at this particular address 100 in order to fetch the operand value. So this is what is resistor indirect mode. In this particular mode, directly within the resistor data was available, operand was available. But in case of resistor indirect, instruction specifies the resistor, so it will specify me a resistor which contains the memory address of the operand. So this particular address is nothing but the memory address of the operand. Where within the memory, in which particular address in the memory that desired operand is present. So saving instruction bits since register that address is shorter than the memory address, right? So slower to acquire an operand than both register addressing or memory addressing. But it is a very slow process because reason is that the registers we are using might be present somewhere else. So first of all, I need to refer to the register, and then from the register, I need to refer to the memory. So ultimately, it will consume a lot of time in performing that. Then next one is the auto increment, auto decrement mode. So the idea is very much clear from the name itself. When the address in the register is used to access the memory, you have used the address, okay, which is available in the register to access the memory. Now the value of the resistor will be either incremented or decremented by 1 automatically. Auto means automatically by itself it will get increment if the mode I am going to use is auto increment. Auto decrement means automatically it will decrement. It will decrease one value which is available within the resistor, and then this auto increment or auto decrement mode will work. Students, you will get to know more about these when I will share one numerical example with you. So once I am able to, once I will clarify you just the general description of these all addressing modes, then we will work upon one numerical, so that you should be having a better idea about how I am able to increment the value of the resistor by 1, or how I am decrementing the value of resistor by 1, because there is a mechanism being used how I am able to perform these operations. I cannot directly apply these operations on these resistors. Similarly, if we switch ahead, so these are the most commonly used addressing modes: direct addressing and indirect addressing. So we are very much aware of this. In case of direct addressing, the value of mode bit will be 0, right? So there could be some, let's suppose, opcode bits and the address bits would be there. So instruction will specify me the memory address which can be used directly to access the memory. So this instruction, this entire instruction is leading me that I need to refer this 100 value which has been present here in the instruction. Okay, this 100 value of the memory in order to get the operand. So this is what is the point in case of direct address. So direct address is given of the operand which is available in the memory. Direct memory address has been provided to me, right? So the next one is there, indirect addressing mode. So in case of indirect addressing mode, so what I need to do is, in order to perform the same instruction, so actually we need to refer to the address of instruction. So this is what I need to do. Okay, so how I can perform that is, again I will reach this 100 value in the memory. In that 100 value, whatsoever data is present, let's suppose it is 102, I need to reach this particular value of 102 in order to fetch the required operand. So idea is, address of instruction will give me the effective address from where I can figure out the exact data. So this is here been written, EA is nothing but this is the effective address. So memory's instruction registers address of address. Okay, so this is what exactly is going to give me the effective address in case of indirect addressing mode. So similarly is the last one, which is relative addressing mode. So in order to understand relative addressing mode, the very first thing you need to understand is that the address fields of the instruction is specifying me the part of the address. Means not exactly how or where you can get the data, but just a portion of, a hint of, you could say that, which can be used along with the designated resistor. So point is that when we are using the relative addressing mode in the address field, like this instruction is having a address field, okay, and then it is will be having the opcode field and the mode bit, right? This address field is helping me, but along with that I need to work with some another resistor also in order to figure out the relative addressing. In relation to some another addressing or resistor, I can actually figure out the exact address of the memory where the data is present. Okay, so address field of the instruction is short. So how we can figure out the data here? So if it is a, these are basically existing in three modes: one, two, and three. So if it is a PC relative addressing mode, means program counter relative addressing mode, then how I could figure out the address or the effective address? Just the value present in the program counter plus the address of the instruction. So in that case, it will be like this. What is the value of the next instruction? Right, and then I have to add it with the address bits or address which is mentioned in the instruction, then only I am able to achieve the effective address. Similarly, in case it is a index addressing mode, right, so then what will happen? In case of index, we are having a resistor with the name index resistor, which is holding some indexed values. So again, the effective address will be calculated by the value of the index register plus these address bits. So here now in the second value, I am going to use the value of the index register rather than the program counter. Then similarly, there is a third which is called as base register addressing mode. So base register is, we are actually considering one of the resistor as a base resistor. Okay, so the address which is available in the base register, I will be providing along with the address mentioned in the instruction. So the idea is, in case of relative, the addressing mode, the address of the instruction works in relation to some another, you could say that the resistor, in order to provide me the effective address. So this is what the points. So effective address is nothing but the address where you are going to fetch the operand value. That's it. So after analyzing all these addressing modes, now is the time when we have to work upon one numerical, so that you should have the better understanding of all the different kinds of addressing modes that we have used so far. So let's understand them by considering one numerical. So here I am using some resistors named as program counter, having the value 200 right now. Okay, there is a R1 resistor. Any resistor, R1 is a simple resistor. Value present here in this R1 resistor is, let's suppose, 400. This is XR resistor. XR here I am considering this resistor as nothing but the index resistor, XR. Okay, so having some value 100 present here, and there is accumulator resistor. Now this is the memory, this entire, this memory is using this, actually this is a to address instruction. So idea is two addresses are being used in order to specify one instruction. So one instruction is being accommodated in the two addresses. So that's why its name is to address instruction. So here, how we are specifying it, this is the mode bit, this is the opcode, operation I have to perform. I have to load the data in the accumulator, and the address of the instruction is been specified in the next memory location. So this is how this entire instruction is working, or the entire scenario is present. We have to figure out the values of different addressing modes which are available by using the values which are present here in this memory. Okay, so let's start understanding about this. So the idea here is that before we used to have only a single value or a single address field which was specifying me the entire instruction. But now two fields are specified here. Okay, one, two, and third, which is the address field, is been specified in the second instruction. So please make sure that you have understood this point, that in this particular example there are two address fields being used to specify one instruction. Okay, so let's understand about the addressing modes in more detail. So the very first one is the direct addressing. Now, before understanding all these addressing modes, there is one point which should be clear to all of you, is that what exactly we are going to figure out from these all examples or from this numerical. We are actually looking for the effective address. Okay, so if I have to tell you about what is an effective address, so effective address is the address of memory where operand is present. Okay, so it is very much important that you should be clear with this data. Now we are about to figure out the effective address, because ultimately addressing modes are helping me to figure out the effective address only. So if it is a direct address mode, we know that the direct addressing mode says whatsoever is the address present in the instruction, directly on that particular address you are going to get the operand, right? So in this case, what is the effective address? Effective address will be nothing but the 500. And at the 500, what is the operand value present? 800 is the operand value present, right? So accumulator will be holding the value 800 when this instruction will be executed in the direct addressing mode. So that's why the content of accumulator will be the 800. Similarly, if it is an immediate operand, so we know that in case of immediate operand, what was happening? Immediate operand was something like immediately I am going to get the data. So whatsoever is the value here in the memory location 201 is actually the value, actually the address where exactly the entire address or the operand is present. Immediate, if you remember, immediately I am going to get the operand. So address field is itself becoming the operand here. So here, just because it is a two address instruction, now I need to specify that the effective address will be 201, and on that particular address 500 is the data available, operand available. Okay, just because its definition is immediate operand, so we are specifying the it immediately. Similarly, the third is there, which is nothing but the indirect addressing mode. So indirect, we know address of instruction will be the giving me the effective address. So here, address of address. So address is this 500. 500 is leading me for the further address 800. So 800 value is the effective address in case of the indirect addressing mode. And what could be the value present here? So whatsoever is the data present here would be the value which I will be storing in the accumulator resistor. Then there comes the next, which is the relative addressing. Now, if it is simply been given relative address, then we will consider it like it is a program counter based relative addressing. Okay, so how we learned that, how we will be figuring out the program counters relative address mode. So I need to use the address of the instruction, right? So address is 500 plus the value of program counter for the next instruction. See, this is the value of program counter for this particular current instruction which we are executing. As we have already started executing it, so the value of next instruction to be stored here should be nothing but the 202. Okay, as it has been mentioned here. So here what we are going to get is 500 plus the value of instruction a program counter for the next instruction, which is leading me for 702 as an effective address. So that's why 702 is the effective address. So I will go to the 702 value within the memory to get the operand value. So operand available here is 325. Similarly, if it is the relative index addressing mode, then how it is to be done? The same manner as I taught you earlier, I need to use the address of the instruction plus the value present in the index register. So what is the value present in the index register? Index register is storing the 100 value, so definitely 600 is going to be my effective address. So what is the value present here in the 600? 900 is the operand. So 600 is the effective address, 900 is the operand value. Then there comes the register mode or register direct mode. Okay, one and the same thing. So directly within the register value is specified. So resistor R1 is having the value. So in this case, I would not be having any effective address because effective address is generated in case of memory address. Okay. So here I am just referring to the resistor only. So directly the data stored in the resistor is exactly the data which I am looking for. So here there is no effective address, but this is exactly the operand value being provided to me. Similarly, if we go ahead with the register indirect, so I have figured out the difference between the two before as well. So here what will happen, indirectly within the register, the operand value to the memory is given. Okay, so this address which is present in the register is specifying me the memory address. So effective address will be the 400 and 700 will be the content available in this register. Means the value of the register is indirectly helping me to specify the effective address of the data or the operand which is stored in the memory. So then there comes the auto increment. So auto increment. So this auto increment works like some data is already present in the register, like 400 is present in this particular register. Okay, what I will do, see if you look here, it is a post increment. I have to first of all update the value, means I have to use the value of the register, and after using it I will be updating the value by one. So what does it means? It means that for the time being I will be using the value of the register R1. Okay, I use that value 400. So 400 is my effective address, and what is the operand value stored in the 400? 700. I am using that 700 value. Now after that what will happen? I will increment the value of this R1 now by 1. After using this 400, okay, now I am going to increment the value of this R1 by 1. So in the auto increment, the remaining value of this R1, the updated value of R1 will be the 401. Similarly, the auto decrement is there. So in case of auto decrement operation, what will happen? I have to pre-decrement it. See, there is a minus before the R1, right? So what I need to do, I need to first of all decrement the value of this R1 resistor by 1. So whatever is the value present here, 400, 400 minus 1 will be 399. So this 399 is going to be my effective address. It is a pre-decrement operation, and increment is the post-increment operation. So then I will be using the value. Whatsoever is available at 399 will be my operand value present within the memory. So I hope that you have understood this entire procedure of addressing modes. And if you have any doubt, you can ping me here. Thank you so much for your valuable time.